So let's pick up where we were, except now we're going to move, like I said, to talking about the perception and judgment of social groups. Now, there are a lot of different major dimensions of in-group, out-group dynamics. So you belong to a group, people belong to a group that's part of, defined by people's race, defined by their nationality, defined by their religion, defined by their age, by their gender, by their hobbies, by their interest, if you're on a sports team, so on and so forth. And so sometimes a thing, though, that social neuroscientists will talk about is a term referred to as the minimal group. The minimal group are basically these arbitrary group dimensions that experimentalists will use to group people on random and meaningless dimensions. So it's a way that as an experimentalist, you can have control over how you're going to kind of do this, because you basically make these groups that are defined completely randomly. So you don't really know, so you have control over, the extent to which people really would identify with them. Because if you start trying to do experiments with things like race, ethnicity, nationality, religion, so on and so forth, you could get a lot of variance from one person to the next with how much they do and do not identify with that group. But presumably minimal groups, people are kind of on the, closer framework to how they view themselves of it. So in a very common paradigm, I'm not making this up, is the Leopard Tiger paradigm, where basically what happens is you bring a person in to do the experiment, and you, as the participant, you would come in and you are randomly assigned to be either in the leopard or the tiger group. It's literally a flip of a coin. And if a participant, you're like, wait, what does it mean to be in a leopard group? You'd just be like, means you're in the leopard group. It's like, oh, is there anything like special about leopard groups? Nope, just you're in the leopard group, not in the tiger group, not in the lion group. Go leopards, boo tigers. Like, that's pretty much it. And you're like, okay, haha, kind of random, because it is random. It is the minimal group. That's literally what it is. So then what would happen is you get assigned to your group, and then you would spend some time learning about 12 strangers, half of whom are in your group and half of whom are not. It's like, this is Lenny, he's in the tiger group. This is Marcus, he's in the leopard group, so on and so forth. Just totally random. You just learn which one's which, okay? And then what happens is you get scanned with fMRI while you're just doing the task of classifying everyone as being either in your group or outside of your group, as being either a leopard or a tiger, okay? So for example, you would see 12 random faces like this. I just picked random people off the internet. I have no idea who they are. And I could just arbitrarily assign them to those 6 are in the leopard group and those 6 are in the tiger group, okay? You learn nothing else about these people except that. You don't learn their names. You don't learn their hobbies. You don't mention anything. You just say, this dude, he is in this group. This woman, she's in that group. This person, they're in that group, and so on and so forth, okay? And so then what you can do is you can just look at in a person's brain, just do a contrast, not of a contrast of like faces over scenes or a contrast of like, objects over scrambled objects, but in contrast of in-group versus out-group. And it turns out that what you find is that 3 areas of the brain seem to pop up. The fusiform, where the FFA is, the amygdala, and the orbitofrontal cortex. And I think the line of thinking goes something like this, that when it's a face that's in your group, you kind of get a little excited. You pay a little bit more attention. You're like, oh, hey, I know that guy. That guy's in my group. I like my group. Hey, I like that guy, okay? And that act of attending to his face, her face, their face, whatever, it's going to cause that brain region to get activated a little more. Think about several weeks ago, when we talked about attention. What is attention to a brain area? It activates it even more. So if you see a face and you pay more attention to that face because they're in your group, the FFA activation is just going to go up. The amygdala, it's a region we're going to talk about next week. I'm just going to kind of hold off on it because we're going to dive kind of deep into it. It's a little complicated, but so let's just put a pin in that for now. And then also the orbitofrontal cortex. Also, just to situate you with what's going on, this little region over here, that actually is the fusiform back here. So it's just seeing it from a different angle, okay? So let's focus for a little bit on the orbitofrontal cortex. So it turns out then the next thing you can do is, after they've learned those groups, is you can tell people while they're in the scanner still, hey, do me a favor, make a judgment about how much you like each of these people. And what you do is you tell these people about how there's actually been a lot of research that humans are really good at determining really, really quickly if they like or dislike someone based on, subtle facial features, first impressions, and so on and so forth. There actually is a whole line of research about this. I'm not making this up, neither are the experimentalists. It's called thin slice perception. And it actually turns out that people can be really accurate with what they're going to think about a person within a couple of seconds. My personal favorite, quick aside, is that there are these studies that are done where you show, let me get this right, you show college-age students like a 10-second clip of a professor teaching, you turn the sound off, you don't let them see anything other than the person. You don't let them see the slides or anything. So you just see a person here, everyone look at me in the corner. You just see a person and a professor doing something like this. Like you see them miming what it's like to teach, and then you give them a survey to like evaluate them as a professor. How available are they outside of class? How helpful are they with questions? Blah, 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 things like that. And you might think like, I would have no idea. I don't know how available they are outside of class. I don't know how helpful they are with questions, but it actually turns out that just from like a 5 or 10 second clip of them silently teaching, people are super, super accurate, because again, it actually turns out that human observers are really good at this sort of thin slice perception. And so what you can do is, as people are going through these phases and now not making a judgment about the group that they belong to, but making a judgment about how much they like those, you can see how the different faces are activating the OFC, the in-group faces and the out-group faces in each participant while they're doing this different task. And it actually turns out that you can predict how much more people rate liking someone who's in their group versus out of their group based on this orbitofrontal cortex region. That basically this particular brain region is giving you a clue as to what the person's views are on someone. And so what you actually can just find, for example, is that there's going to be something like they're going to say that they like their in-group more, and you can see that reflected in their brain. They're going to say that they like their out-group less, and that's also reflected in their brain. So it just actually turns out that you can see this really instantiated neurobiologically in this particular region called the orbitofrontal cortex. But again, I want to really reiterate that this is a situation where what makes people like us, or, you know, same or different from us, is very arbitrary, okay? It's about being in the leopard group or the tiger group. But this just goes to show you how quickly we naturally can become biased against people who aren't like us in very arbitrary ways. So then it makes more sense to, it makes sense to kind of understand how then this could scale up about how there might be in-group, out-group dynamics when you get to less arbitrary things like nationality, the college you attend, hobbies, religion, so on and so forth, and things like that. And these sort of natural preferences and biases are easily reflected in our underlying neural activation, okay? So a natural question to wonder, though, is this process fast or slow, okay? So is it the kind of thing where our brain needs to be like, oh, that's that guy, I recognize that guy, he's a tiger, I'm a leopard, and so I don't like that guy because since I'm a leopard, you know, do you go through this whole line of thinking? Or is it more of a type of quick thing that you can do naturally without even really thinking about it? Now, a question like this that I'm asking, you can't really answer with fMRI, because remember, fMRI is slow, it's tracking blood flow, so that's not a method you can use. What method could you use then to kind of look at the time course of these biases? You would use a method like EEG. So then some follow-up experiments had this idea of like, all right, you know what, let's take EEG and let's see what happens to the N170 when you're looking at faces that either are in your group or not in your group. And just to remind you, the N170 is a face signature. So this is a person over here. All these little black dots are electrodes, just to remind you. And we're going to look at some of these electrodes that are back here in the occipital lobe where vision is. And we're going to show people all these different stimuli, okay? And 0 is when the stimuli come up on the screen. And what we notice is that there's this negative voltage potential called the N170. It's about peaks at about 170 milliseconds. And you can see the blue and the red. The blue and the red correspond to faces, okay? So they're like, now that we know we have this face signature, the N170, let's see what happens to it when you're looking at faces that are in your group or you're looking at faces that are not in your group, okay? And in that situation, what we find is something that looks like this. It actually seems as if very early on, our brain is making a distinction between faces that are part of our group and faces that are not part of our group. And again, this is just the difference between something like tigers and leopards, something very arbitrary, not particularly important. But even something as arbitrary as this, we can see that after 170 milliseconds, our brains are already making these sort of snap judgments. And I think that this is very interesting because this shows that very quickly, these sort of preferences and biases for different groups of people become so ingrained in us that they seem like they're almost happening automatically. I don't know about you all, but if you show me a face, I don't really think I can make the decision to have one view of that face or another within 170 milliseconds. 170 milliseconds, it's less than 1/5 of a second. So this is really thought to be a bottom-up type of process. And so this data is showing us how our brains note people who aren't like us very early on, even for these somewhat arbitrary dimensions, okay? But you can still wonder, though, about could these sort of arbitrary decisions that you make about biases and preferences and so forth, is it happening truly automatically, or is it just that you have to kind of be in the same mindset? Because up until this point, everything that we've been talking about has always been about tigers and leopards and tigers and leopards, okay? But what if like we grouped them on another dimension that had nothing to do with anything we'd even mentioned about, okay? Might not make sense yet, but I think in 2 seconds it'll make a lot more sense. So there was another experiment where you bring people in, you're randomly assigned to being either a leopard or a tiger. You spend some time learning about 12 strangers, half of them are in your group, half are not, and you're gonna get scanned while you're classifying each person as being in one group or another. Here's the difference, here's the added twist, okay? This time, okay, half the faces are also gonna be the same race as you, and half the faces are going to be a different race as you, okay? But remember, you're doing the leopard tiger task. Race is totally irrelevant. It is never mentioned, okay? The experimenters don't say anything about race. The experimenters don't talk about race. The only thing that they ever talk about is things like leopards and tigers. What you see, though, could be some sort of diverse group of students who are participants, half of whom are the same race as you and half of whom are not. But again, this is never, ever, ever mentioned, okay? And so even in this situation, when half the faces are the same race and half are not, even though you're doing this totally different task and it's never mentioned, you still find that you can look at the brain patterns and you can see that the brain patterns automatically note the difference of the same difference race conditions. In a sense, social grouping is noted and processed automatically by the brain, even when it's not relevant to the task at hand. Because in this particular situation, what is most relevant to the task at hand? What is most relevant to the task at hand is, in its entirety, this distinction between leopards and tigers. But even so, there's then like a sort of a sub-level of biases and so forth that come from another dimension of something in this particular case, like race. And so I think this just speaks to this idea that since the brain is processing these things even when they're not relevant, it just kind of reflects, I think, its natural intuitions that there are cases where people might be predisposed to liking people for one group or be biased towards someone because they belong to one group that's like them. Say if you're part of the same, I don't know, you're an athlete at Williams College versus an athlete at Amherst College, but you can be biased against them because they're part of a group that you are not part of. And so there are all these kind of conflicting in-group, out-group dynamics that are kind of vying for attention and are kind of vying for neural circuitry in your underlying cortex. And so it actually just turns out that once again, we can really see this reflection of in-group, out-group biases in your underlying neurobiology. Just to give you a quick heads up about what you're going to be reading about this week, the article that you're going to read, it's relatively short, called Do You Feel My Pain? It's actually showing how group membership on the dimension of race will modulate how much empathy you seem to have for someone. That basically what they did is they recruited Caucasian participants and Chinese participants, and you would see these people who are in the experiment experience something painful or something not painful. And it actually turns out that if you are, that depending on what racial group the participants involved in the study belong to, if they are Caucasian or if they are Chinese, their brain will show more or less empathic responses for people that are more like them or less like them, and so on and so forth. Okay, so then let's take a quick break, and when we come back, we'll talk about, not talking about how groups influence you, not talking about how you perceive and understand these other groups, but in this case now, how you will perceive and understand the minds of other individuals, kind of how you think about other people thinking about things that are different from what you're talking about. So when we come back, we'll talk about understanding other minds and so forth.